All right, practice test. Here we go. I'm going to do a digital. You can do a digital. We're just practicing. The test is really what matters. Okay, f of x is 3 plus the absolute value of x minus 1. What's f prime of x at x equals 1? I think the best thing to do is to figure out what this graph of f looks like. And f is 3 plus x minus 1. Okay, so this is going to be low. Okay, so at 0, that's 0, 4. Then when we put in 1, we get 3. When we put in 2, we get 4 again. Okay, and we know what absolute value graphs generally look like. And so f prime of 1 does not exist. If you're going to say something is not differentiable, you can't just say corner. You have to basically show that the derivative does not exist. So we're going to do a little bit of cheating here. We're going to say the limit as x approaches 0 from the left of f of x minus, it's not 0, it's 1, f of x minus f of 1 over x minus 1 does not equal, this is the formal definition of the derivative, or an alternative version. So over x minus 1. And so we really can't say, well, you just kind of have to prove that something doesn't exist. And the cheating part is here. We know we are writing the formal definition of the derivative, and what you should know is, you know, this part on the right-hand side of x equals 1 has a slope of 1, and the left-hand side part of f, the left-hand side of x equals 1 has a slope of negative 1. So that's going to be good enough there. A little more straightforward on problem number 2. Find f prime of pi halves. So we have to find f prime of x first, or at least we should. And f prime of x, well, the derivative of sine is cosine, still of 2x, chain rule times 2. So f prime of pi halves is 2 cosine of pi, and cosine of pi is negative 1. So f prime of pi halves is 2 times negative 1, negative 2. All right. On this one, hopefully you see that x minus 2 squared and cosine of 2x are being multiplied, so we need a product rule. So the derivative of a product of two functions is the first function times the derivative of the second function, and I'm going to put that negative on the derivative of cosine way out front, and let's see, that's a 2x, so chain rule times 2 out front, plus the second function, cosine of 2x, times the derivative of x minus 2 squared, so 2 times x minus 2, and the derivative of x minus 2 is 1. Okay, so f prime of 0 is negative 2 times 4 sine of 0. I should have done that first because this whole thing is 0. And let's think ahead. Cosine of 2 pi, or cosine of 2 times 0 is 1, 2, and then 0 minus 2 is negative 2, and we can ignore that one at the end. So f prime of 0 is negative 4. Realize I did not have good notation. Okay, there we go. Cosine of e to the power x, just a chain rule on the cosine. Ooh, two chains. We're going to have to remember to multiply by a negative 1 on the derivative of e to the negative x. Okay, so f prime of x is negative cosine. Inside that cosine is e to a power, which has a derivative of e to that same power, negative x. And I'm going to go ahead and change this plus out front of cosine to negative. Maybe I'll rewrite that, but we don't really have to. E to the x cosine, e to the negative x, cosine of e to the negative x. So I'm hoping you've memorized the derivative of 1 over x like I've told my students. The derivative of e to a power is e to that same power. That power is 1 over x, which has a rate of change of negative 1 over x squared. So we're going to say negative e to the 1 over x squared is the derivative of f. Hopefully these are going along pretty well. Derivative of arctangent of 2x. So let's say you forgot how to do a derivative like this and there's not a y equals. You can go ahead and remake, hey, y is equal to arctangent of 2x. Tangent of y is equal to 2x, and that sort of stuff. I'm not going to do it that way because I happen to know the derivative of inverse tangent is 1 over 1 plus the input squared. That input is 2x, which has a rate of change of 2. So we'll go ahead and multiply everything out. 2 over 1 plus 4x squared. Another reason you want to multiply these out is in the future, we're going to be doing antiderivatives, so you'll have to do all these things in reverse. And it would be good to have those ahead of time. All right, on number 7, that's a product rule, but I think I can avoid doing a product rule. So if we wanted to, we can think of that x as the square root of x squared. Oh, no, we can't. I'm just thinking now that might change things because we can have... No, we can't. I was going to say we could get a negative out of the original x root 3x minus 1, but we can't because any x value that would make the x out front negative would make the radicand negative. So I think I'm good. And so that's going to be 3x squared, 3x cubed minus x squared inside of there, because we can just do square root of x squared times 3x minus 1. Okay, so the derivative of the square root is 1 over 2 square root, and the stuff inside is 3x cubed minus x squared, which has a rate of change of 9x squared minus 2x. I think that's the best way to go. The product rule is going to be much uglier. Okay, so I was thinking implicit differentiation, but it's not. We're taking the derivative of y with respect to t. So I guess we're doing a quotient rule here. We can't really simplify at the beginning. I bet at least one of you writes dy dx. Denominator t times derivative of the numerator 1 over t minus the numerator natural log of t times the derivative of the denominator all over t squared. I think I gave this one to you guys when we were first doing derivatives of logarithms. I think that's pretty good. We need to read a little bit more. Okay, let f be a differentiable function such that f of 1 is 5, f of 2 is negative 3. F prime of 1 is 4, f prime of 2 is 2. The function g is differentiable, and g and f are inverses. What is the value of g prime of 5? The first thing I'm going to do is figure out what g of 5 is. And g of 5 is 1, because f of 1 is 5. So I suppose the easy way to go is to have memorized that g prime of 5 is going to be 1 over f prime of 1. So 1/4. If that's not good enough for you, let's change the color. Don't forget the definition of inverses we could just say, and we don't need both halves, f of g of x equals x and g of f of x equals x. You can just choose one. And if you do that, we do f prime of g, g prime, just chain rule, equals 1. G prime of x is 1 over f prime of g of x. And g prime of 5 is 1 over f prime of g of 5. And wouldn't you know it, one of the first things I wrote down was that g of 5 is 1. So g prime of 5 is 1 over f prime of 1, like I had originally said, memorized, whatever. But that's a nice backup in case you forget the relationship. All right, so if y squared minus xy plus x squared equals 1, then in terms of x and y, dy dx equals. Why does it say in terms of x and y? Because you're allowed to or expected to have x's and y's in the derivative, not just x's like you're used to. So we should be doing implicit differentiation. The derivative of y squared with respect to y is 2y dy dx minus a product rule, x times dy dx. And then I'm just going to not have parentheses and do minus y times 1. I could have done minus x dy dx plus y times 1 and then distributed the negative later. Okay, and then, the derivative of x squared is 2x, derivative of 1 is 0. All right, we're not substituting in values, so we'll just do some algebra. On the left-hand side of the equal side, we'll factor out a dy dx, and we're left with 2y minus x. On the right-hand side, let's add y and subtract 2x. And then, hey, we're home free. Y minus 2x over 2y minus x. Realize if you did this in a different order, you actually might get dy dx is equal to 2x minus y over x minus 2y. Hopefully you can see that if we multiplied by -1 over -1, we would get everything the same. I just know people get freaked out, especially on multiple choice where their answer looks similar but doesn't quite match. Okay, is that, no darn it, that's not the same equation. Okay. So if xy squared minus 2x equals y to the 4th minus 1, then at 0, -1, dy dx equals blank. We'll do implicit differentiation, but we're going to save a ton of time and effort if we substitute in 0, 1 really early. So x times 2y dy dx plus y squared times 1, that's my product rule. Derivative of negative 2x is negative 2. Derivative of y to the 4th is 4y cubed dy dx. Then we're going to be using 0, -1. So this first term, I'm just going to write 0. I'm not going to bother substituting, because if the x is 0, the whole thing is 0. And then that's -1 squared times 1 minus 2 is equal to 4 times -1 cubed. And that dy dx is what we're looking for. Okay, let's take our time here. So -4 dy dx. And on the left-hand side, that's +1 minus 2 is -1. And so divide by -4, 1/4 is dy dx. I think that's good. Okay, so we're going to write the equation. Did I lose my pen again? Well, let's try saving. So that writes backup pen. Technology. Anyways, equation of the tangent line to f at 218. So I already know the equation of the tangent line to f at 218 is going to have the structure y minus 18 is equal to slope times x minus 2. I can even do that first. I think the easiest way here is product rule instead of multiplying everything out. So first function, x times derivative of the second function, derivative of something squared, 2 times that something, and that something is 2x minus 1, which has a rate of change of 2, plus the second function, 2x minus 1 squared, times the derivative of x, 1. And we might as well put in 2 right now. So 2 times 3 times 2 plus 3 squared times 1. How about f prime? So 8 times 3 is 24, 9 times 1 is 9, and f prime of 2 is equal to 33. So we can just fill that in down here. Okay, so we're finding the slope of the tangent line to natural log of stuff at x equals 0. So we just need a numerical value. All right, what are we going to do here? Okay, derivative of natural log. I'm going to leave the numerator blank because I know it's not going to end up being 1 with my chain rule. 1 over the input. That input is 1 plus e to the power 2x. And the rate of change of 1 plus e to the power of 2x is 2e to the 2x. And then we'll say dy dx evaluated at x equals 0 is 2e to the 0 over 1 plus e to the 0. We can actually drop that dy dx we can drop the evaluated at x equals 0 part. So that's 2 over 2. And we can leave it like that, but we might as well say 1. Okay, position of a particle moving along a straight line at any time is given by that. Find the acceleration of the particle. Acceleration is the second derivative of position. So we're going to do v of t is x prime of t. V of t is 2 cosine of 2t. Let's zoom in a little. And acceleration is v prime. So acceleration is negative 4 cosine of 2t. You just get an extra chain rule there. So a of, is it pi fourths? Is negative 4 cosine of pi halves. And cosine of pi halves is 0. I don't know if it matters how things are graded. If you simply wrote the acceleration is 0 without any supporting work, you're pretty much getting no points. You need to show kind of everything. This question is implying you need to find velocity and acceleration, and you need to show those derivatives. We are reviewing this. I'm not going to give you position, velocity, and acceleration on next week's test because that's really in Unit 3. But we might as well do these. The particle moves along the x-axis, so its position at t is that stuff, where time is greater than 0. Find all values of t when the velocity of the particle is 0. Okay, so again, velocity of t is x prime of t, which means velocity is, oh, it's just a chain rule thing. Okay, so 5 stuff to the 4th. and that's a t squared minus 1, which has a rate of change of 2t, and we're going to say let velocity equal 0. And so t squared minus 1 to the 4th times 2t. The reason we have things factored is we just, like back in algebra, we could say, we can ignore the 5, we can say t squared minus 1 to the 4th equals 0, which also means t squared minus 1 equals 0, which means t is equal to positive or negative 1. Or 2t equals 0. T equals 0. And we reject the negative 1 time. We're saying time is greater than 0. The velocity of the particle is 0 for t equals 0, t equals 1. Cool. Hope that helps.